maybe that's what he
Okay, all, we'll begin in a second. So if folks wouldn't mind settling in. Okay, I think let's begin. It's extremely late for Richard, so I just want to make sure that we don't go longer than we have to. Oh, hi, everyone. Welcome to the Oblivious HTTP Application Intermediation Working Group session at IETF 116. We are your chairs, Siobhan and Richard. This is about, yeah, this is the IETF Note Well. Please do note it well. By participating in the IETF, you are agreeing to follow IETF processes and policies and code of conduct. So please do read that at some point. Some general notes for the meeting. Shh, guys. Some general notes for the meeting. If you're here in person, then please do use the on-site tool for queuing up. It helps with queue management. And if you're remote, then just make sure that your audio and video are off unless you're presenting or chairing or speaking. And as a reminder, there's a mask policy. Masks must be worn. And there are no exemptions, and unless you're an active speaker, which means basically here. Yeah, we have note takers, so thanks to Chris and Martin for agreeing to take notes. Also wanted to say that the main protocol draft OHTTP has been submitted for publication. It is in the RFC editor queue. And there was a few discussions that the authors worked through, and thanks to them for that. And I think congrats to the working group for doing this.
Yeah, big thanks to the authors for working through some complicated discussions there.
Yep. Thanks, Richard. And yeah, I think we can begin. Tommy, did you want to present? Yes. It says you have control.
It says I have control?
Try again.
Yeah, here we
There you
go. All right. Good afternoon, everyone. So, as we know, our core OHAI documents are shipped. So, I will be talking about our other adopted document, which is about one of the discovery mechanisms that we can use for OHAI, specifically how we can discover the gateways. And I'll jump right in. Great. So as a recap to what this is doing, this is for a model where we have some target service that we're trying to access as an oblivious target resource that has an associated oblivious gateway. And a client would like to discover that this target has an associated gateway. The client is assumed to already have or already know about an oblivious relay. And one of the constraints for this model that came out through the discussion and the analysis was that the gateway and the target for this type of discovery essentially have to be co-located or at least have their resources on the same origin. So recently we did make a round of updates for this right before the draft deadline for IETF. It was based mainly on the things that we discussed last time, so these things should not be hugely new. One was a lovely bike shed. We renamed the SVCB parameter and all of the other strings to OHTTP. They used to be oblivious, but OHTTP works better and is also more consistent with the core doc. So yes, this influenced the well-known URI. And then the other major thing is that we clarified the behavior for using oblivious HTTP for DNS. So I'll go into a little bit more detail of this. So here are the examples. We had shared these before, but now they're updated. So they have in green the strings that are OHTTP instead of oblivious. So again, a lovely bike shed. But just so we walk through what we actually are doing here, we have a DNS record that we get back when we're looking up a particular service, and along with other things like the ALPN, it can have a parameter that says, I support OHTTP, which means that there is a gateway associated with this. And so this can happen for an HTTPS record, it can happen for an SVCB record, such as an SVCB record that is describing a DNS resolver. So once you have that information, the client could look up they can derive the location of the oblivious gateway, and they can also look up the key configuration. So the oblivious gateway is defined as a well-known URI off of the same origin as, off the same host as the target service that you're trying to access. And this gateway, it could, redirect you or something, but it has to be owned by that same origin so we can be sure that it actually is a safe thing to use. And then to get the key configuration, we have a way to also go find a well-known location to look up the keys. So then the other major clarification was around the DNS behavior. So this is the model where you have OHTTP being used to transport DOE. And so this is do, which or duo. I think we actually should pronounce it duo, is the new mechanism here. Similar to Odo, but it's a different spelling, so it's duo. So essentially this is just a case where you have standard binary HTTP, oblivious HTTP messages to the gateway. The content of those binary HTTP messages are DOE messages. And so it's quite straightforward to just compose those two protocols. And you can discover this using the dns.resolver.arpa, which we've defined from the ADD working group. So that's a great way to learn that the local network you're on and whatever IP address you had configured for your DNS resolver also supports connecting over Duo. And we did note that when you're doing this, we still need to have all of the server certificate validation that is required when we're discovering a DNS resolver in this way. And this, I believe, is actually a pretty straightforward thing to do, since we have to fetch the key configuration anyway for the oblivious HTTP DNS server. At the same time, we can validate that it has the certificate that matches the requirements of a discovered DNS server. So that's the changes that went into this most recent version. You can read the diff yourself as well. So I guess, as a preview, my next slide will be, I think the main issue we have left is consistency. I would love to hear if we have other issues beyond that, but I think the major gap, which we talk about a bit in the document, but I think needs to be fleshed out further, is how we have good models for consistency. And there are two main areas of consistency that I think are relevant here. First, we have the key consistency. So we do have the key for the oblivious gateway, and that we look up with the well-known URI. There are different approaches you could do here. So we could have our double check type of approach where we do like a get style reverse proxy, potentially using the oblivious relay to find this. And then we could also do like a forward proxy style and check that the key config that we get in both manners is the same. You could also just have a model where you check once directly through like a connect proxy, and then you also ask your relay, hey, what do you think the key config for this target or for the gateway is, and see if it's the same. This, I think, all needs to be written out in more detail. I would love to hear people's input on what we should do here. Chris, do you want to comment on this one?
Yeah, in the Privacy Pass meeting on Friday, there's going to be a section dedicated to key consistency for that particular protocol. I imagine whatever comes of that particular work would equally apply here. So I don't know if you're looking for a specific like standardized mechanism or more like considerations for consistency.
I think that is a question of, for mechanisms like this in general, consistency is very important to get right to actually have the security model we expect. So to some degree, is it enough to just point out vaguely to you must do consistency? That's one extreme. We could have another model where we mention and describe non-normatively several of these approaches and how they work. And we could have a more extreme model where we give like a really detailed algorithm and try to be more normative about it. But that's probably going a bit too far.
Yeah, my sense is that since we were comfortable doing the first option for Privacy Pass, that we could just do the same thing here and then like lean heavily on that like informational draft and potentially like a more mechanical standards track draft that comes of that work. So that is, don't put any like stuff in here, just say like see consistency. You must do consistency, see this other document for information. Yeah. That seems like a reasonable outcome here. Because like the consistency thing might take a long time depending on how complicated we ended up trying to make it, or not intentionally try to make it complicated, but like the actual solution that we might end up like standardizing might be more than double check, which is like, pretty simple.
Right. I mean, I do find it a little bit unsatisfying to merely punt on consistency. If that is not fleshed out, I would potentially lean towards, pointing out to, do whatever consistency eventually says you should do, and maybe give one concrete example of here is a way that we believe works of, some form of double check or a check with relay approach.
I guess I'm curious, like why we're treating Privacy Pass differently in this case. Like we don't do that for Privacy Pass, which also has like very like important consistency requirements in order to like achieve the desired properties. Whatever we do here, we should just be consistent across these two things. No, that's pretty meta, but like, yeah.
Maybe we should double check our approaches. Okay. Ben, do you want to go ahead?
Hi. So I agree that the key consistency problem is the same as Privacy Pass key consistency problem. We should say the same thing here as we say at Privacy Pass. The dope path consistency problem is quite different. And
yes,
I don't have a very strong opinion about how we ought to solve that. I think it's worth doing something. I think that limiting it, like just declaring it that it's a default or limiting it to a default is like kind of inflexible but not unreasonable. But having that default be /DNS query strikes me as a little bit of a problem because it squats on a portion of the valid HTTP namespace. And in the past, when we've tried to do that, the HTTP purists have told us that we are in the wrong place and that we should go to .well-known. And so, like, maybe we can just hard code a path in .well-known for this.
That's an interesting point. I mean, I think to some degree it's the unfortunate nature of DOE that we don't use a well-known, but every single doser I've ever encountered uses the same path, and it is /DNS query. And we could do something, cagey, like if the client receives an extremely common path, i.e. DNS query or something else that comes along that standardizes a well-known, then it's not interesting to try to double check or verify that your path is consistent. If you get a weird path that you've never seen before, then you should check it and make sure you're not being targeted.
Yeah, I mean, the history here is that Doe originally tried to say we're just going to use a .well known, and at the time, that also, basically we got told .well known is for static metadata. This is not metadata about the origin, so you can't put it in .well known. But maybe it seems like maybe the treatment of .well known has changed since then. So, but anyway, I think we'll be able to come up with some kind of solution here, and I'm happy to help with that.
Cool. But yeah, it is a good point. I agree with you that even if we copy the text from Privacy Pass for key consistency, the Doe path consistency is a unique problem, so we should address that in this document. Okay, Eric.
Yeah, mostly I agree with a lot of people have said. There's very complex stuff that has to happen with these key consistency, and Privacy Pass is working on drafts specifically for that, and so we should let those be the primary drafts for key consistency.
Right.
I do think we need to reference them in this draft, though. We do need to say you must use some sort of key consistency mechanism. Here's the draft that specifies the generals how to do it. Here's a specific one that we recommend using. And I think that's the right way to go. We need to have them. Privacy Pass has similar problems and is working on them. And it was a thing in Privacy Pass that, hey, these could be worked on either OHAI or Privacy Pass. We need to pick one and set it up in Privacy Pass. Those are the drafts we should be using for key consistency, at least. Yeah. Great. I fully believe we need to point to one of them. And besides just that reference, though, this draft, unless there's a little bit of, hey, here's the parameter you use specifically for doing it with OHAI, there's not a lot of room for specifics other than pointing to those and saying, this is what you use.
Thank you. Okay. So update to point to Privacy Pass key consistency document, add some text about Doe path. And I guess the last question is, do we think there's anything else that we should address in this beyond that? Or once we've done that, can we wrap it up? Put a bow on it. I'll take silence as a yes. All right. Thank you.
Thanks, Ravi. Tiru, did you want to come?
Yeah, just to put a bow on that discussion, it sounds like we can start working your last call once Tommy gets a new draft that addresses the outcomes we talked about here. So thanks, Tommy.
Did you want me to share?
Yeah.
Thanks. Hello everyone, I'm Thiru. I'll be talking about AWS relay feedback draft. We had presented this draft, I believe, a couple of times at the IETF. Next slide, please. Yeah, a quick recap on that is basically if there is a overload on the target, then how would it signal the overload back to the relays so that it would start rate limiting the clients, but at the same time making sure the rate limit does not de-anonymize any of the clients. We are basically leveraging the HTTP rate limit headers to publish quotas and service limits to the relays and not to the endpoints. Next slide, please. Yeah, so one of the major feedback that we got when we presented this draft at the last session was don't do any rate limiting for a client or subset of the clients, even with all the mechanisms that we had, because that could possibly be misused by a malicious target. So what we have done is now we have removed all those mechanisms which were discussing rate limiting a client or subset of clients. And now it basically talks about rate limiting all the clients, and we have used normative language to say that the relay is not supposed to rate limit a client or a subset of the clients. And we are pointing back to some of the discussions with regard to if the relay decides to rate limit all of the clients, then how would it do that? It should be serving a large number of clients, and it should be still processing a good amount of messages from them, and discussing back to some of the correlation avoidance that's discussed in the OHAI draft. Next slide. Yeah, so we have introduced a new OHTTP target quota policy parameter that gives a signal back to the relay that this rate limit policy is specific to the relay, and it can opt in to apply the rate limit, or it may decide to skip and not honor these rate limit policies. Next slide. I think we have addressed all the comments that we have seen so far, and we think it looks ready for working group adoption.
Yeah, Chris Wood. So I've read the draft, and I guess I'm not sure I understand like why we actually need this in practice. So for context, like Cloudflare runs an OHTTP relay and has not needed this. So is there like a use case or a deployment that we know of that would actually benefit from this mechanism?
Yeah, one of the threat vectors that we had looked into was like if there was an overload scenario that was created on the target and it wants to rate limit, right? Then it would start rate limiting all the clients, and there is no fair distribution of the requests that are coming in. So a message back to the relay will help a fair distribution and not to penalize all the clients, for instance.
Sure, like I understand like in principle that this is like potentially useful. I guess I'm wondering of like people who have actually deployed this and run relays, if they would actually use this and consume this signal and like use it for the benefit of like perhaps protecting the origin.
At my previous organization when I was working for Akamai, I mean, I heard from some of the folks who have worked on this that they found this useful, but I no longer work for the organization, so I can't comment right now.
I think like it would be very useful to know if they could come, like if they could like state their interest in potentially using this thing, because that seems like a useful signal to consider whether or not we adopt this. But from my perspective, from Cloudflare's perspective, we haven't had a need for this, using this thing at scale.
Well, so Chris, it seems like the need for this would be driven by gateways or targets, because you're trying to preserve the uptime of that resource. I think the salient question for relay operators would be more whether they would actually consume the signal and do anything with it. You know, if some poor gateway they were interacting, you know, said, you know, please don't send me so much. Like, is that a signal that you could usefully respond to?
I guess that's what I'm saying. Sorry, like we have not gotten a request to potentially rate limit in any particular way. So, like, we wouldn't use a signal, I guess. Does that sort of clarify?
Yeah, I think that's what I was asking you.
Okay, great.
And I think that's an interesting point. So I think to clarify Chris's point, the useful feedback here would be from operators of gateways or target resources. You know, is this a risk that you're running into in practice? And from operators of relays, is this a signal that you would respond to, or that you're hearing from the gateways and targets you're interoperating with, that this is a concern they would want you to respond to? Ted.
Ted Hardy, this is sort of a mildly related question because it goes to the part of the document which describes the impact severity. So you're pointing off to the business severity thing that Roman has. And I think there's no difference, as far as I can tell, in the document that describes anything you would do differently as a relay, depending on what the severity is. And you don't pass that information to anybody. So I'm a little bit unclear as to why it's being included if there's no expected difference in behavior depending on what it is. And I'm guessing that it kind of relates to this, right? That maybe you're just trying to track how often people tell you that there's a problem, and how often when they tell you it's a problem of what severity it is. But if there's no like evidence that this has been kind of strongly correlated with activity in the past, I'm not sure that this parameter is doing anything if in fact the mechanism is needed at all. So maybe you could explore a little bit what you were intending in including that. Is it just simple telemetry, or were you really thinking it was a key to maybe later behavior?
Yeah, the attack severity was not added in the initial one, but when I got feedback from the people who had implemented the OHAI relay saying that at least they would like to see the severity levels and decide on that whether to act on the rate limit or not. So if based on some configuration knob they would have, like if attack severity is high, right, then the idea was to rate limit. If the attack severity is low, then wait for such signals, multiple signals coming in, right, to see if the attack severity is increasing, and then apply it. So it sets a threshold or an alarm bell to raise an alert, and then to watch out what's happening, whether the attack severity is increasing or it stays like that.
Okay, so I think if that's the logic behind it, you probably want to add that text to the document to describe that logic, because that would be helpful.
Sure.
And I think you also probably want to be pretty careful, because that sounds like a set of things where you'd say, hey, I'm going to obey the rules about not doing correlation and targeting, except if I get one that's really high. And it really sounds like a place to hang the kind of business logic to ignore some of the issues that are in the security and privacy considerations. And I don't think that's what we want. Thanks.
Sure. Thanks.
Hello, Tommy Polly, Apple. Thanks for presenting this. So to follow into this conversation, I guess, to Chris's point, I think we haven't seen a need for this in the existing deployments, but I think kind of in defense of this, the existing deployments we've seen, there aren't that many of them, and they're relatively new. And I think they do follow a model where we do see pretty explicit trust, or like we know some guarantees about what the relays are doing, how the gateways are set up, et cetera. So one potential area I could see us wanting to explore more, and maybe this could even be explained in the documents for the types of deployments where you'd want this, is if there is a weaker relationship potentially between the relays and the gateways, or there's less confidence in the relay validating what users come in, right? So like when we are currently doing stuff with oblivious HTTP, there's enough attestation of clients that there's already rate limiting going on before you get through the relay, and you can trust that the relay is doing the right thing. If at some point people start deploying totally open relays that just let anyone in the world come to them, then maybe that will change. But I think it's good to think about this in context of what are we assuming the relay is doing and the trust model, and when is this actually applicable or not? The other part that may be interesting, and I don't think this is something that the authors can answer, but I think we'd want to hear more from implementers, is that I think there are going to be more use cases that start adopting oblivious HTTP, for example, like a safe browsing type use case, and there may be services that start using it at a different scale, or that have different fraud prevention requirements that maybe will be interested in this. So I think, I don't know how we coordinate this, but if people have an intent of working on OHAI deployments who haven't done it yet, who maybe haven't needed to use it, do they anticipate they will need to have it in order to allow them to use this more broadly?
Yeah, and the service discovery is one such aspect where I see like ISPs would start deploying the relays, right? And it would communicate with any target which is a public DOH server, right? I think that's where it makes more sense. I mean, some of the threat analytics that we had done was, I mean, at my previous organization was like, do we have to put a WAF, right, to identify any of the HTTP request attacks and all of that? But this was probably the most simplistic attack that we thought we'll start with before we see a realistic world of attacks where it would happen, and then only it makes sense to come back. But yeah, as you say, as the deployment catches up, we will see more and more actors using it, and we will see what kind of realistic attacks happen. So this is I believe the 101 attack that would be the starting point before they move to more emerging attack vectors.
I just wanted to say one quick thing. Tommy raised a really good point that like this is really quite early in the I guess the overall use of OHTTP, where deployments are kind of just starting up. So perhaps sitting on this until we see a need for this in actual practice seems like, you know, the correct thing to do. Or perhaps there's like a new use case that you were talking about with like different like trust relationships that might warrant this particular type of thing. But maybe a more like concrete use case will emerge in time, in which case we can revisit adoption. But when the way that the draft is currently written, in the way that the sort of trust relationship are currently like set up in practice, it doesn't seem like that bar has been met. But like that doesn't mean like that won't change. Either we'll lower the bar or the bar will be met eventually, or it might not. But let's just maybe wait a bit and see how things go.
Sure.
Hi, Alex Chernowski. I wanted to ask if there is a assumption in your draft about the size of the deployments, because listening to the issues that were just brought up, it sort of sounds to me like there's an implicit or possibly explicit assumption that the Oblivious gateway is deployed at larger scale than the Oblivious target. And it's not obvious to me that that's actually going to be true in general. Because if you go and look at regular HTTP resources today without looking at any of the Oblivious stuff, it's usually the responsibility of every target to somehow defend itself against denial of service attacks. So whether that means using like a first-party CDN or a third-party CDN or something else, it still seems to me that you would need to have the capability to defend yourself directly from attacks, even if they were going through one of these gateways. So my question is, does that change here? It still seems to me that like the target would need to have, especially if it has also non-oblivious resources, quite substantial serving power. So like, does this draft actually in its current form do anything other than provide like an advisory signal to the gateways to, if they're polite, that they should do this? Because otherwise, I don't even understand how in the trust relationships that you were describing earlier, how if it was done like as ISP operators, that anyone would do anything other than best effort follow this. It doesn't seem like there's any way to enforce it without having the target be able to sink any attack. And at that point, the target's sinking the attack. So I'm struggling a little bit to understand how the ecosystem concerns would actually turn into an effective deployment of this right now.
Yeah, in typical target deployments, like you say, right, targets do have firewalls to defend them from various types of attacks, right? With CDNs absorbing DDoS attacks at very large scale, right? That's a default deployment, right? One of the default policies is to basically identify the attacker and then basically create ACLs to basically block that target and all of that techniques. But with the anonymization that's happening, it's some of those mitigations are no longer possible. So this is acting as a way to see if this feedback could be taken and a policy could be enforcement. But if the relay is loosely coupled, it may not even enforce these policies, and we could imagine an impact on the service that it is providing to the clients if the policy is not enforced. It's not a strict policy, right? I mean, there's no feedback back from the relay back to the target whether the rate limit is applied or not. So
David Skenazy, proxy and relay enthusiast. I'm struggling a little bit with this draft because I find that on one hand, it is kind of too vague and it's not clear like exactly when this is needed and like, you know, what assumptions it's having about the size of the deployment and the types of deployment. And on the other hand, it's also a bit too specific to HTTP and too specific to rate limiting. Like there are many other aspects that, like if you're running a mask proxy or a regular connect proxy, you can have similar problems where there is abuse or DOS or anything going through them, and having maybe a way to tell them that there's a problem might be useful. But to kind of go back to Chris Wood's point, we haven't, so like
I'm at Google. We have a partnership with Fastly to use OHTTP for things like safe browsing, and we haven't seen the need for this yet. And so my gut feeling would be to say, like, not throw this out, definitely not. I can see this being useful in the future, but not yet. And once we get there, we might learn that maybe it's not rate limiting that we want, it's something else and other things. So that would be my personal opinion, would be to not adopt at this time, but not in a way to tell you that we're never going to, but it feels a bit too early right now.
Well, thank you, David, for the excellent segue to the wrap up I was going to try and do here. So Sean and I have been chatting in the background. It's kind of sounding to us like the authors here have addressed a bunch of the technical feedback. And at this point, it's sounding like folks in the room don't really have kind of technical blockers or differences in approach to that would be bars on adoption. It's more a question of whether there is enthusiasm or demand for this this functionality. So what we were going to propose is that we actually go ahead and do an adoption call and use that as the way to measure whether there's enthusiasm and energy for this functionality. So it'll be a little different from your usual adoption call in that there won't be sort of presumed adoption. So it'll be an actual open question adoption call. So I'll encourage the authors and those who are interested in this to get some interested voices and get those opinions on the list. But I think we can, given that we have addressed a bunch of technical questions and we've seem fairly aligned on the general approach here at this point. I think the chair's proposal would be to go ahead and issue that adoption call and use that as the tool to measure whether there's interest in this. Anyone have concerns about that approach? Come to the mic real quick. Seeing no one leaping up, either virtually or IRL, I think we can go ahead and get that on the list pretty soon here. All right, thank you, Tira.
Thanks.
Cool. That was productive. Do we have any other things people want to talk about? Because going once, going twice. Richard, did you have anything else?
That's all on my end.
Cool. All right then. See you all next time.
Thanks all.
We can do a round of applause for the publication or imminent publication, I think. Just on the note, that would be perfect.